Hello everyone, and thank you for joining me for today's topic. We're at topic 12. You've reached this topic because you found a link in the course notes and you clicked on the YouTube icon. So please, before we proceed, make sure you download the course notes onto your device of choice. Don't just rely on finding the course notes through Brightspace, because you never know when you're going to lose access to Brightspace. Great. Let's get started. Today we're dealing with topic 12, and that is specifically an introduction to section 3.4 of the Ontario Building Code, exits. Okay? Very well. Before we move on, I just want to remind us all what we covered under topics 10 and 11. Specifically topic 11, we covered these two items, that is access to exits and means of egress. Okay? So if you haven't viewed topic 11 and read the course notes for topic 11, please stop this video and go and do topic 11. Otherwise you'll be quite lost for this. So exits, the topic we're covering today for topic 12, is very similar to topic 11. So there's no point in you doing topic 12 unless you've done topic 11. In fact, what I'm going to say is, as of right now, I'm going to try to get a card to appear at the top of this video so it can link directly to topic 11. Maybe I'll introduce that as a link also in the description to this YouTube video. So, a reminder of what we covered in topic 11. First of all, we started off with a little bit of safety within a floor area, of any floor area for a Part 3 building, and specifically relating to suite protection and public corridor protection. Okay, so how to safely make it from anywhere to a floor area to, but not through, an exit. Okay, that's what the previous topic was about. Then we also went on to do a few examples related to figuring out the width of the corridor to get us to an exit, right? Remember that. And finally, we also talked about dead-end corridors and what that means, and access to exits and doors, suite egress doors, right? Remember, not exit doors, but egress doors. And did they swing outward, inward, why not? So this is kind of a reminder of what we covered. If this doesn't sound at all familiar, stop right now and go do topic 11. So exits will be set up. So this topic is set up very similarly to topic 11. Okay, so you'll notice that compared to topic 11, I'm not going to go into much depth because my assumption is you've already done topic 11, and I won't repeat everything that was covered in topic 11 because if it applies to topic 12, it's already covered. Okay, let's start off first of all with what the building code defines as an exit. This is review. Okay, we looked at this under topic 10. I'm just going to read a little bit what I found in the building code, but before I do that, do you remember where I find definitions in the building code, right? That's under Division A, in this case Part 1. And exits mean that part of a means of egress, including doorways that lead from a floor area to a thoroughfare or an exterior open space. Okay? So basically, when it comes to this floor area that I've reproduced for you in your course notes, these here's are considered the exits, right? They're the areas that are shaded. They're built specifically and identified specifically in Part 3 of the building code as exits. And if you remember, I think what we discussed is that an easy way to figure out if you're about to go through an exit or where an exit is if you see these signs above them, right? By law, in Ontario, a legal exit must be identified as such. Okay, so let's start off first of all with exit stairs and fire separations and fire resistance ratings of exit stairs and what the building code says. So under sentences 1 and 2 of Article 3.4.4.1, every exit shall be separated from the remainder of a building with a fire separation of an FRR not less than the floor. And in addition to that, the FRR for that exit cannot be less than 45 minutes and doesn't have to be more than 2 hours. So here's what I want to point out. The first item here says that the minimum fire resistance rating of an exit is that of the floor assembly. And we learned how to figure out the fire resistance rating of a floor assembly, right? Remember when we went through those 63 different articles? Okay. And look at this though. Not only must it be at least what the floor FRR is, but it cannot be less than 45 minutes. And it doesn't need to be more than 2 hours. So the reason this is important is, well, for a number of reasons, which we'll touch on in a moment. But let's play around and see basically how this affects us. So let's do a silly example. If the floor resistance rating then of a floor assembly in whatever Part 3 building we're looking at is 1 hour, then the fire resistance rating of the exit, according to these two sentences, must be right. It says it has to be at least that of the floor. So if the FRR of the floor is 1 hour, then the FRR of the exit must be at least 1 hour. If the FRR of the floor assembly is nil, and by that I mean that we found out we don't need a fire resistance rating for a floor assembly, then what is the fire resistance rating of an exit? Right. According to these two sentences, it must be at least 45 minutes. Okay? If the FRR of a floor assembly is more than 2 hours, what is the FRR of an exit? It's allowed to be 2 hours. Okay? So this is kind of the implication of these two sentences. Now let's look at the big picture implication of this. Okay? These two sentences basically say the exit stairs always must have a fire resistance rating. Always. No exceptions. Also, have we come across yet any part of a building, Part 3 building, that must always have a fire resistance rating? I don't think so. Or maybe we have. Think about it. And why is it this important? So another way to look at it is, in the event that there is a fire in the building, what do you think, according to Part 3 of the building code, is your best bet for being safe in the event of a fire? What would be the safest place in a building, Part 3 building, in the event of a fire? I'll leave that with you to give it some further thought. Okay? All right. When it comes to exit also, just like we saw for topic 11, all exit doors, enclosures, must have a fire resistance, fire protection rating that is rated in accordance to subsection 3.1.8. So first, basically, what this subsection says is you have to check to see if that closure is allowed to be a 20-minute closure. If it's not, then you must go to table 3.1.8.4. Is this looking familiar? It should, because we did the exact same thing, and it's done exactly the same as in topic 11. I'm not going to cover this in more detail, so if it doesn't really make sense to you, do topic 11. How many exits does Part 3 say that a Part 3 building must have? Well, as a rule of thumb, according to sentence 3.4.2.1, 1, 2. Okay? But there are some exceptions that relate to less than 2 stories or up to 2 stories and a whole bunch of other stuff. I've written that link here, and also go check out that in the building code because it's written in your course notes. You're expected to know the exceptions. How about then the minimum distance between exits? We know you need at least 2 exits per floor. How far apart must they be? Should they be as far apart as possible? As close as possible? Well, the building code does have something to say about that. I've given here for you 2 layouts. One that shows exits that are super far apart, one that shows exits that are super close together. Okay? And there needs to be a balance about how far or close the exits are to allow just about everybody in a floor space to access them safely, right? Everybody must have a fair method of getting to an exit. Okay, so you can't disadvantage one tenant more than another. And that's where the building code provides requirements for distances between exits. So let's look at this. The building code says that, under 3.4, basically the minimum distance between two exits, okay, two exits, shall be half of the maximum diagonal dimension of the floor area, with two exceptions. If you have a public corridor, the maximum distance is 9 meters between two exits. If there is no public corridor, the minimum distance is 9 meters. So look at this. The two differentiating things between max and min 9 meters is whether or not that floor area is serviced by public corridor or not. So we'll go back to topic 10 and 11 to figure out how do we know if it's a public corridor. What does the building code say about that? Because I'm not going to go over it again. So let me give you more of an algorithm to figure out what the distance, if it's more than 9 meters, less than 9 meters. Okay, let's try this. What is the minimum distance between two exits? Does that floor space have a public corridor? If the answer is yes, then the maximum distance between exits is 9 meters. No more. Black and white. Does that floor space not have a public, so it's not a public corridor. If it's not a public corridor, the minimum distance is 9 meters. So it must be more than 9 exits, okay? More than 9 meters in distance between exits. Not sure? Let's try it again. Is this a public corridor that you have in a floor area for a Part 3 building? If the answer is yes, then the maximum distance between exits is 9 meters, no more. If it's not a public corridor, then the minimum distance between exits is 9 meters. It can be more, but it cannot be less. Okay? That's basically how it works. So maybe let's practice this a little bit. Okay? 1/2 of the maximum diagonal of a floor area with a public corridor is 8.8 meters. And in a moment we'll get to how to calculate this half diagonal dimension, okay? But you're told right now, public corridor, yes, and this half diagonal is 8.8 meters. What is the minimum distance between exits? Using our algorithm, it's 8.8 meters, right? Because if there is a public corridor, yes, the maximum distance is allowed to be 9 meters. You get 8.8 from the half diagonal, so 8.8 is acceptable because it's not more than 9. Okay, here's another one. You get that half diagonal is 18.75 meters, and it is with a public corridor in that floor area. So what is the minimum distance between exits? So again, public corridor, yes. Half diagonal, 18.75 meters. So it has to be 9 meters, because if you do have a public corridor, the maximum distance between exits is 9 meters. So even though you calculated a half diagonal of 18.75, you can go up to 9. Okay, you calculate this half diagonal, and again, I'll show you how to calculate this half diagonal, and you get it that it's 8.8 meters. No public corridor. So what is the minimum distance between exits? If you go to our algorithm, it is going to be 9 meters. Because if there is no public corridor, then you're allowed to have a minimum distance of 9 meters. Okay? But not less than 9 meters. How about if you have no public corridor, and this half diagonal is 18.75 meters? What is the least distance between exits? Well, if you remember from our algorithm, no public corridor means 9 meters minimum. So is 18.75 allowed if you calculated it as the half diagonal? Yes, for sure. Okay? So maybe, how about we figure out exactly what the heck this half diagonal is and how to calculate it. Okay. So let's say you have a floor plan of some sort. There's a floor plan on the left that is a very simple box, okay, and it's a Part 3 building, and there is one on the right that's a bit more involved, kind of more like the ACE building, right, where there is jots in, jots out, okay. You find the maximum length, the longest dimension in length, the maximum width, you connect those 2 points across, and that's your diagonal. Half of that diagonal is your half diagonal, okay. So once you figure out the floor area like this, then you use that half diagonal as your starting point to determine the distance between exits. Okay? And how do you do that? You come to the most delicious theorem there is, the Pythagorean theorem. Okay? And if you remember, it basically says that c squared is equal to a squared plus b squared. C squared is the diagonal squared, and a squared and b squared are the adjacent and the opposite. Okay, the two sides, if you will, of that right angle triangle. So if you want to find what the length of that diagonal is, you just take the square root of c squared, or the square root of a squared plus b squared. Okay? Which then means that if you want half the diagonal, you take that value and divide it by 2. That's simple. Okay? So let's practice from your homework. Okay? I plucked this out of homework 7. It's an example, and it's not in your course notes because it's part of your homework, and you're going to do it as part of your homework. We have a floor area. The length of this floor area is 13 meters. The width is 10 meters. There is a public corridor. Okay? So there is a public corridor. That's the very first thing you always want to check. So then we move on, and we figure out what is that half diagonal. Because we have to figure out what the least distance has to be between these two exits. So half diagonal of the floor, but because it's a public corridor, that distance cannot be more than 9 meters. So we do 10 squared plus 13 squared, square root of that divided by 2, and I get 8.2 meters. Make sure you can get this calculation. You can do it, okay, and get the same number. 8.2 meters is less than 9 meters, so that means that these two exits you see here have to be at no more than 8.2 meters apart. Now I'm looking at this, they look like they're at more than 8.2 meters apart, which means that now the architect has to figure out a way to position these exits closer together. Or how about adding a third exit somewhere so that now these three exits are at no more than 8.2 meters apart. Make sense? So again, the least distance now between these two exit stairs must be 8.2 meters, which may mean that if you want to keep two exits, you have to readjust their location by law for a Part 3 building in Ontario. Okay, let's do another one. I took this again from your homework 7. I think it's example 4 in homework 7. We have a floor space measuring 66 meters wide by 36 meters long. First thing we ask, is there a public corridor? I don't see a public corridor here. So that's maybe because this whole floor in this Part 3 building is owned by the same tenant, right? There aren't different suites. There might be corridors, but they're not a public corridor. So then we have to figure out what the least distance is between the two exits by calculating the half diagonal. But now we know that this half diagonal distance can be more than 9 meters, but not less, right? So 66 meters plus 36 meters, both of them squared, square root divided by 2, I get 37.59 meters. So that means that I'm allowed to have these exits at least 37.6 meters, okay? Because it's more than 9 meters. I just can't go less than 9 meters. Now, here's an interesting question. Let me just see where I am. Okay, yeah. Here's an interesting question, okay? And then I'll take a bit of a break and go on to part 2 of the video. Why does it matter if it's a public corridor or not? And the distances can vary quite a bit, right? No public corridor, and suddenly you can make your exits as far apart as you want. The difference is in the fact that with a public corridor, it means that that floor area has multiple tenants, and each tenant, right, in each suite must have the same allowance in getting to an exit as every other tenant, right? So that's why exits need to be a lot closer together. If there isn't a public corridor on a floor area, that means there is only one tenant on that floor. Okay, that tenant is either renting out or owns the whole floor. So now you don't have multiple tenants to get out. You might still have multiple people, but not multiple tenants. And as such, you only worry about one tenant on that floor if there is no public corridor, and therefore exits can be further apart. Alright, I wanted to let you know that on Brightspace, a reminder from topic 11, I uploaded these two drawings for you, which you can use to see how the ACE building deals with some of the exits items we'll be discussing for this topic. Okay, but go find them, because I haven't uploaded them for you in topic 12 because they're under topic 11. You're more than welcome to download these drawings onto your device of choice. Okay, which means that these drawings are now fair play for tests and final exams. Okay, all right, and that's because if you look into these drawings, you'll see example exits on the 4th floor of the ACE building. Okay, which are these right here, and you can figure out. Is there a public corridor here? Are they spaced apart at the minimum distance that is expected or not? Why not? Okay, so go check it out. Okay, so the next item we'll chat about is the minimum required width of exits, but I think this is a good place to take a break, so that's what we'll do. The next video, we'll start with the minimum required width of exits. Thank you for your time, and I'll see you shortly.